going to be this thing. Oh, it didn't. Yeah, you can.
I'm gonna say it pause.
Yeah. Yeah. Behind the camera here so that it doesn't.
Good evening. How's the volume? Great. Okay. Awesome. I'm Angela Butler. I'm an administrative assistant in the president's office at South Carolina. Just want to say thank you for everybody attending today. Also to everybody attending online, thank you for coming. There will be a question and answer session at the end of the presentation. So save your questions for then. Those of you who are online, if you have any questions, go ahead and type them into the chat for the Q&A, and I will ask them and get answered live at the end of the presentation. Steam Cafe is a partnership with South Dakota Mines, State Brewing, and South Dakota Pork Products. So we thank them for their support. We've been doing this since April of 2018, and we couldn't do this without you guys. So thank you all for coming. Without further ado, our presenter for tonight is Anya Hartpence. She's a volunteer NASA solar system investigator.
Hello. How's everyone doing tonight? Okay, got a shy group tonight. As Angela mentioned, I am a NASA Solar System Ambassador, and I am. Let's try this.
No, you're all set.
Okay. So again, my name is Anya Hartpence. I'm a NASA Solar System Ambassador, and I'm going to talk to you tonight about Landsat. Landsat is going on 50 years of operations. Has anybody heard of Landsat? Oh, excellent, a handful of you, almost everybody, that's awesome. Little introduction, this is a little, what we're going to go through tonight. I'll go into the introduction, talk a little bit about the Solar System Ambassador Program. Then we'll do an overview of history of Landsat, since a lot of you have heard of Landsat. That's really exciting for me, and I shouldn't have to dwell on that too much. The uses of Landsat, and then we'll get into the imagery, which is always the best part. So the Solar System Ambassador Program is a NASA JPL project, and it's volunteers. Anybody can be a NASA Solar System Ambassador. There is an application process. You apply, and then they check your references and so forth. It's just like a job. You do have to have an interview and everything. But then after that, it's an exciting opportunity to talk about sciences to everybody. They encourage STEM operations throughout the year. A requirement is for STEM opportunities throughout the year. And it can be any ages, from preschoolers through adults. You can talk in a bar. How wonderful is that? And the other requirement is you have to go through their ethics training, which don't take bribes to talk about science one way or another. And then you also get full swag. So after I'm done talking, you are welcome to go back. We have some calendars and stickers back there. And the application process starts August, September, you usually know by October whether you've made it into the program. It's usually, I don't know, they're looking for so many volunteers from South Dakota because there aren't a whole lot of us out there. So if science is something you really enjoy and appreciate, I would encourage you to check it out and apply. And the program is just Solar System Ambassador. Put NASA on that and you should be able to find it. So when we talk about Landsat, now let's get into the meat of our program and talk about Landsat. Again, this program has been going on for 50 years. The first Landsat satellite was launched in 1972. At that time, it was called ERTS. ERTS stands for Earth Resources Technology Satellite. Our satellites are launched out of Vandenberg Air Force Base in California. Today, that's been changed to Vandenberg Space Force Base, in case we didn't get the memo. And most recently, Landsat 9 was launched from Vandenberg Space Force Base, and that happened in September of 2021. So we have had a total of 9 satellites that have been launched. So some interesting things about our satellites, they travel at 17,000 miles an hour. When I tell that fact to kids, they just love it. They go, ah, amazing, it's awesome. And our satellites travel, when they're traveling 17,000 miles an hour, that means they go and orbit the Earth about 99 minutes around the Earth. So that's pretty fast, pretty good time. About 14 orbits a day, so 14 times a day, the satellite orbits the Earth. They are polar orbiting satellites, so when you see me doing this, that means from pole to pole around the Earth is how they orbit, as opposed to like a geosynchronous satellite, which stays at the same location around the Earth and travels like this. Normally I'd ask questions, but since we're waiting to the end, we'll discuss that more if anybody has questions then. 30-meter pixel resolution. So the earlier Landsat satellites, Landsat 1 through 3, had 60-meter pixel resolution. Today's satellites 4 on through 9 have 30-meter pixel resolution. There's also a pan band on these satellites. The pan band will allow you to pan sharpen your image to 15-meter pixel resolution. And that's really useful for agriculture, for urban development, things of that nature. And when we talk about imaging the Earth, we're not actually taking a picture of the Earth. We use the electromagnetic spectrum to capture light's reflectance off of the Earth. So as the sun comes in, all of that light is then reflected back, and as the satellite goes over the Earth, it captures those reflected rays. We're using the electromagnetic spectrum. We're not actually taking a picture of the Earth. We're using the infrared, the visible spectrum, to image the Earth. So here we are with our timeline for the Landsat satellites. Landsat 1, 2, 3, those are our MSS satellites with RBB. MSS stands for multispectral scanner. RBB stands for return beam Vidicon. Landsat 4, Landsat 5. Landsat 5 actually is the Guinness Book of World Record holder for longest Earth imaging satellite. These satellites on average have a design life of 5 years. Landsat 5 lasted 28 years. It's a pretty good return on investment. Landsat 6 had a little blip. It launched and it failed to achieve orbit. Not very many people talk about Landsat 6. Landsat 7, we just decommissioned Landsat 7. We decommissioned Landsat 7 in order to make way for Landsat 9. Landsat 7 is currently the record holder for most images, or I shouldn't say that, a record holder. In the Landsat series, it's the record holder for the most images. Many, many millions of seeds from Landsat 7. Landsat 8 and Landsat 9. We don't know when Landsat 9 is going to launch, but we have expectations that it will last a long time. So I mentioned the electromagnetic spectrum. Now, the electromagnetic spectrum is around us everywhere. Microwaves, radio waves, we use the electromagnetic spectrum every single day. And this is the visible spectrum. So of all this electromagnetic spectrum, the portion that you and I can see is just very, very tiny. It's a pretty small portion of the electromagnetic spectrum. Landsat, though, actually allows us to see more than just the visible, because we also use the infrared and we use thermal, which is not listed there. But having those extra capabilities gives us more applications, more practices that we can do with Landsat. And here is the different bands that we are able to accomplish or able to see with the different satellites. Every time we launch another satellite, we can improve it just a little bit. So the MSS satellites really were able to achieve that much of the electromagnetic spectrum. And now we're achieving so much more with these other satellites. When I talk about the electromagnetic spectrum and what we can actually see, this image is done in natural color. So this is what you and I would be able to see. And just to point out some things, we see some development over here. We see lots of clouds. We see probably some rivers. Natural color, we see a lot of green and so forth. And then there's maybe a water body here. Does everybody agree with that? That's what we can see. Now, when we add an infrared layer, there's definitely a water body. You can actually see the outline of it coming up through here. You can see the heat signature from the fire. You can see previous burn scars from fires from before, and this is a recent burn scar from this fire. Lakes, very awful kind of area. I'll go back to the last image. So having those capabilities, being able to access different parts of the electromagnetic spectrum, really do give us more capabilities, allow us to see more parts of the landscape. So let's delve a little bit deeper into the multispectral scanner. And I believe I talked about most of this already, so I'm just going to show you some imagery. We're talking about 50 years of data. That's 50 years of things that we can see with these satellites. So we saw the Mount St. Helens eruption. This was the before. This is Landsat 1. And this is an after. This is Landsat 4. That's a pretty significant change. And that's just with our Landsat MSS sensors. If we were to look at Mount St. Helens today, we would see all kinds of regrowth over that area. We would see ash diminishing. Some other things we might notice is this is September and this is May. We see some harvesting in this area. We see, and I should also probably point out, this is means healthy vegetation in this image. And so the fall season is upon us. You see some of the leaves have probably started to drop. May, spring is upon us, so the leaves are starting to come in, probably full force in this image. So the next series of satellites, Landsat 4 and 5, were Glucomatic mapper satellites. This is when we started. We brought the orbit down. I guess I didn't mention this. The MSS sensors were a little bit further up than the Glucomatic mapper satellites. We brought them down. They're now 438 miles above Earth's surface. And that's when we also went to 30-meter resolution. We saw Chernobyl. They said, oh no, Chernobyl's out. We don't have to worry about Chernobyl anymore. And I don't know if you're able to see this. There's a red dot here that says, oh no, actually Chernobyl is not out. We see the heat coming from Chernobyl. And then we see the regrowth. This is 2015. So we know that things have changed there. Nobody goes to Chernobyl anymore. There's no agriculture being practiced there. Everything's growing in Chernobyl now. Lots of wildlife. It's been taken over by wildlife and vegetation. Donia, Brazil, again, 50 years worth of data. We can really start to see how things have changed in Brazil. They call this fishbone patterns. They put in a road, and then all of these, they call them fishbones, coming off of the side. 1986 through 2006. Massive change happening in Brazil. Usually it starts with fire, slash and burn practices, and then goes into agriculture. After the TM sensors, we had the enhanced TM, enhanced thematic mapper satellites. That's Landsat 7. And I'll talk about the data loss anomaly in just a moment. A major thing happened with Landsat 7 that we were able to capture. The day after 9/11, we caught the World Trade Center burning. And this is again natural color, and this is with an infrared applied, so you can see the difference. In 2003, Landsat 7 had an anomaly happen. All of our sensors through Landsat 7 were something called Whispering. It's a type of technology that scans from side to side. Now, Whispering technology wears out. And in 2003, the Whispering technology wore out, and it caused a scan line anomaly. So ever since 2003, Landsat 7 has had these lines. It causes a 22% data loss for Landsat 7. That means, of course, that 78% of the data is good. There are no lines in 78% of the data. But all images do have, since 2003, these lines. We have developed a number of different ways to overcome those. There's backfilling, there's interpolation, some things like that, interpolation. And so there are ways to overcome these lines, but now that Landsat 7 is decommissioned, we have Landsat 8 and Landsat 9. There might be a moot point. So on to Landsat 8 and Landsat 9, the two workhorses that are active right now. Two sensors, the OLI, which stands for Operational Land Imager, and the TIRS, the Thermal Infrared Sensor. We went from 12 bits on Landsat 8, again, we're always trying to improve our data, to 16 bits that are active with Landsat 9. And we can really see with these images much higher resolution. This is another Landsat 8. This is Kuwaiti fires before, during, and after. And now we're getting straight into the A STEAM Cafe is a lot of science, technology, engineering, and then we have art. There's a series called Earth is Art online. In addition to all the uses for science that the state provides, a lot of it is just quite beautiful as well. And then, of course, there's the science. And I did find a bunch very regionally located and some that applied to some of the professors I've met around here. So, what happens in North Dakota? James River. Oh no, that's the Red River, North Dakota, isn't it? Sorry. So James River is in South Dakota. And every year you have ice flows that back up the water and the water comes through and it doesn't have anywhere to go and so it just kind of expands all over the place, doesn't it? That happens in South Dakota, doesn't it? Algal blooms. That's something that's becoming more and more prominent across the globe, especially in the Great Lakes. This is Australia fires from a couple of years ago, with increases in temperatures, with drying of the environment. Fires have been on the rise. I threw this one in the last talk that I went to. There was a professor who was talking about lithium mining, and this is the Salar de Atacama in Chile. People have been able to use Landsat data for exploring mines, for watching illegal mining, and this is not illegal mining here. This is legit, but it's just beautiful too from the sky. It's something interesting to look at. Burning. This isn't burning. This is bark beetles, actually. This is, I don't know if it shows up very well from where you're at. This is a before image, and then here there's some red, which indicates bark beetles. That's something else that we've been monitoring pretty closely is the issue with bark beetles. They come into an area, and without the freezing in the winter, bark beetles are able to continue to overtake an area, and they go from location to location to location, and they breed, and they destroy the habitat. And we've had that here, haven't we? We've had a little bit of an issue with bark beetles in this location. Does anybody remember a hailstorm by Pierre a few years ago? So another application of Landsat data is insurance companies can come in and they can say, oh, yeah, we definitely had issues with weather. And this is the natural color again, this is the infrared. So farmers can say, oh, my crops were destroyed. I need to reevaluate my year. I need insurance or whatever the case may be. Or they can say, oh, no, we're good. We've got excellent crops here. We have excellent crops here. But it's become a very valuable source for agriculture. And insurance has found it to be a very valuable source too, because if Farmer Brown, hopefully hear his name Brown, Farmer Brown says, yeah, I lost 300 acres. And the insurance company can say, oh, no, you didn't. Your land looks great. But, Farmer Joe says, well, my wheat got flattened. Well, clearly, Farmer Joe up here is wheat flattened. So there's a lot of commercial applications, I guess, also with Landsat. So we also have watch the regrowth, and we can go in and we can say, was it healthy regrowth? So there's green here. It's not quite the same green though, is it? Is it regrowth that is healthy? Is it invasive species? So with Landsat, that's another thing that we have the capability is evaluating regrowth after a fire. Are invasive species invading? Is it Canadian thistle that's coming in? Or is it some kind of scrub? Or is it healthy trees that are coming in and growing back? Like this there. You can see the difference in the greens, can't you? So Yellowstone, poor Yellowstone's always getting hit with fire. And that's another thing that we can monitor closely and we can see and evaluate. Well, all of these all of these trees are coming in, or are they trees? Are they scrub? Are they valuable, or are they invasive? So that's another application that Landsat has, and it's been very beneficial to scientists across the nation. And last but not least, I'm going to leave you with a beautiful image of Landsat 9. This is the only Landsat 9 image I have in here. Since it was just launched, we've been waiting for a big event, volcano, fire, something. It's going to happen. I had a demo prepared, but to show you how to load Landsat, but instead I think I'm going to show you Earthshots page. Oh, sorry. It's just amazing. We get so much imagery and you can really see change occurring right before your eyes with the repeat cycle. It's almost like it's happening in real time. And this is the car fire, or when's the car fire, when's the Mendocino fire a couple of years ago. And a lot of people ask me, so you have this billion-dollar contraption in the sky and it's imaging the Earth. Why? What good does it do? And I think you have repeatability. You get the same location every 8 days with the 2 satellites. So with 1 satellite, it's every 16-day repeat coverage. With 2 satellites, it's 8-day repeat coverage. And you don't have to plan flight with airplanes. You don't have to plan big campaigns with drones or anything like that. They're up there. They're basically, what's the word, maintenance free, and they will image the Earth continuously. That's one big push for satellites. Greater field of view. With these satellites, we see so much of the land, so we can image so much of the land at once. Now, if you're studying a pond in Rapid City, probably aren't going to get much benefit from Landsat with the 30-meter resolution imagery. But if you're looking at something like Yellowstone Park, it's perfect. If you're looking at Beetles in the Black Hills, this is perfect data for you. And then global coverage. It's expensive to go study in Africa, but you can study Africa from here with Landsat data, and then take a trip once a year and do your ground truthing. And so the global coverage is excellent is an excellent use for Landsat. So let's get my demo, and I'm going to show you an Earthshots page really quick, and get out of the way of the. Maybe, there we go. Maybe I will, okay. For applications and 50 years worth of data, Earthshots is this phenomenal website. And it will show you study areas, anything that you're interested in. So if you're interested in urban, coasts, fires, forests, anything, glaciers, it will take you and show you these locations. And it will show you years upon years upon years of Landsat data. Again, 50 years of Landsat and all the change that is occurring. So out of curiosity, what kind of studies are people doing? Agriculture, forests, fires? I usually have a pretty interactive group. Let's do forests since we're in the middle of a forest.
Show us the birds.
Oh, you doing some glaciers? Okay. Should we look at the ice shelf? There's a big news story, Filchner ice shelf, and then it broke apart. Am I right in front of it? You can see the break, and then it completely disintegrates. And there are all of these wonderful glacier. Well, there's all kinds of wonderful things out here with showing glacier change. And disintegrating. Mount Kilimanjaro. I always wanted to climb Mount Kilimanjaro before the glaciers disappeared. And the glacier is right here. And it's gone. Anybody else want to say anything?
I get a question about the sports and the conflict or the interest between wood cutters and the national forests, differences of opinion, too much cutting, not enough cutting. Have you got information that you can share that shows us what is going on with the forest?
What is going on with the Black Hills? I don't have any opinion on that. Okay.
It's fine.
It's interesting. I used to fight fires many years ago, and the way the land is used, if it's wildlife preservation land, for instance, the rules for fighting fires is very different there, where they have to allow fires to go through and burn, versus commercial. Well, obviously, if there are people living there, you have to protect, or residential rather, you have to go in and you have to protect those homes and so forth. And so there's absolutely no way you can let a fire burn there. And commercial, well, you want to save the commercial land, you want to save that so that people can protect that and cut it down for commercial purposes. And, I don't know that, obviously I would have imagery to show what's going on in the Black Hills, but I don't know that I would have any insight into like why it's one way or another. for instance.
You would still have to say that ground observers, understanding that you still have to say that ground observers, you know, what the ones that are just showing us.
Well, it's more, when I look at the Black Hills, and when I was preparing my demo for this, I picked imagery from the Black Hills. I was going to show Rapid City, and I was going to show the software is massive, and it takes a really long time to load. So I didn't think this setting was actually going to work for it. So when I was pulling the data, and I pulled 85, and I did pull a Landsat 9 image from May 6th, I think, and the areas, the Black Hills look full. I mean, we have our fire scars, we have a few fire scars and so forth. There's a few meadows that are bare, but when you look at the Black Hills from Landsat, it looks full. It looks beautiful. Like I said, there's always going to be a few fire scars and so forth, but when I look at aerial photography from years ago, my day job, I'm a contractor to USGS Aeros, where the data is archived. We have aerial photography from 30s, 40s, 50s, etc. In the Black Hills, because of the practices, because of the fires and so forth, there weren't nearly as many trees. And I think a lot of that, and I don't know if you know who Paul Horsted is, he does side-by-side comparisons of Custer's troop through here and imagery from like a few years ago, photographs. And you look at those side by side, and there were hardly any trees back then. So the Black Hills are beautiful, and I think their forest management is doing a pretty good job. When I look at years, if I'm comparing years from before to now, I think we have a pretty good forest. I mean, we did have some burning, or we did have I keep saying burning beetle. My mom lives in Custer, so they always have the burning beetle, which that's not it. The bark beetle. I know that there's been an issue with that, and I do see, the bare spots from that too, driving back and forth to see my mother in Custer. So I know that there are some bare spots out there, but I think by and large the Black Hills are beautiful. I think we have a lot of trees. Yes.
So the satellite images have adequate resolution so that you can look at a particular area of Black Hills and identify old growth versus not economically viable, the dogger pines. That's kind of where we are. Hills, the logging industry. The loggers want the older, larger trees, larger diameter, but we're out of those. We have a lot of the younger, but not economically viable trees. So does the satellite imaging allow you to distinguish from that?
Yes, you can do that. Yep. There is, when I was showing you the imagery of Yellowstone, where you can see the difference in the greens, and even when we were looking at the MSS data of Mount St. Helens, there are differences in the reds with the infrared projection or composition. You can see differences in vegetation. You can tell even the difference between corn and soy in agricultural fields. So there's a whole library of spectral, it's called a spectral library, and it'll tell you what the difference is between corn, soy, pine, spruce, etc. So yeah, you can tell the difference. It would take people who do these kinds of studies have been doing them for years and understand what they're looking for when they look at these images. So someone who just downloads a Landsat image and has never done this before is probably not going to recognize the difference. It takes an eye. It takes you know, some amount of training, but yeah, there are ways to distinguish between ponderosa pine and blue spruce, and in the summer aspen or anything else. So yeah, and if you go online and look at Spectral Library, it'll tell you what the differences are. Good question. Any other questions? So I have a theory, and Landsat 4 and Landsat 5 were built at the same time. And Landsat 4 was launched, and Landsat 5 they held on to until an appropriate time. So whenever anything went wrong with Landsat 4, they were able to tweak it on Landsat 5. So I think that's one reason. And then another reason, Landsat 5 was built to hold a lot of fuel. And so there was so much fuel on Landsat 5 that it could just stay up there. And these are 438 miles above Earth's surface, so refueling previously was not an option. Landsat 7 was built to be refueled, and at the time they thought, well, we'll lower Landsat 7 and then we'll just boost it back up again. But that never happened until just recently they started a new program called OSAM, and I'm sorry, I forget what the acronym is, but it's a refueling mission, and Landsat 7 is currently the preferred satellite to get refueled. And it's a maintenance satellite. OSAM is a maintenance satellite built by NASA, and they're going to launch it. It's going to be able to tweak things on satellites. It's going to be able to refuel satellites. It's going to be able to adjust orbits of satellites, and they're going to use Landsat 7 for their, I can't think of the word. Anyway, it's their trial satellite. So, but yeah, Landsat 5 was built with a lot of fuel. So, and for those of you that don't know, these satellites are built with fuel for making adjustments to their orbits. Their Earth's gravity just pulls them back down slowly, so that every once in a while they have to get raised just a little bit. And then you probably noticed on some of the images of the satellites that they've got solar panels. Well, the solar panels are used to monitor and to adjust any of the electronics. So the electronics are run by the solar panels, and then the fuel helps to keep the satellite in orbit. Any other questions? Yes. What? So every 8 days, a new image comes in, one from Landsat 8, one from Landsat 9. Is that your question? Okay. Every 8 days. So some people ask, well, why don't you have more of a repeat? There are a lot of commercial satellites out there. Planet is one, Maxar is one, and they have a lot of satellites, and they're constantly imaging the Earth. And during growing season, the Landsat satellites were predominantly built to image the Earth, and a lot of people are really excited about the growing season. And during 8 days, a lot of people have decided, well, 8 days is enough to monitor our growing season. And so that gives us a good overall look at what we're doing. Landsat Next, the one that will come after Landsat 9, they call it Landsat Next. We could call it Landsat 10, that would be fine too. They're talking about anything's on the table for that. That might be 2 satellites, it might be a hyperspectral satellite. There's a lot of question about what Landsat 10 is going to be, and if it is multiple satellites, we might have more of a repeat coverage. So it's up in the air. Any other questions? Yes.
The old Landsats, are they still boarded, or do they board and function back to Earth?
So Landsats 1 through 3, all of the satellites are still orbiting except for Landsat 6. Landsats 1 through 3, prior to, I can't remember what year it was, they thought that if you pushed the satellites further away, that Earth's gravity would just let go and they would just float off into space. They now know that Earth's gravity is stronger than that, and so the first 3 satellites are still falling back to Earth, but they're still higher than the science orbit that the satellites are in. Landsats 4 through 7 have been lowered. They aren't in the science orbit, which we're talking about for these active satellites. They've been lowered to, I think, like 300 miles above Earth's surface. I can't remember the exact orbit, but the current writing or the current legislation is that satellites need to deorbit on their own within 25 years. And so currently they're all still orbiting. Any other questions? Anything online?
You're online.
Are they controlled out of east or south Dakota, the Baltic? There's an Eros something facility over there.
So all of the data is archived at USGS Eros, and calibration for the data happens at USGS Eros. Anything that, if the satellite should need to be adjusted, pitch, yaw, roll, if it needs to be elevated, if it starts to deorbit a little, that comes from NASA Goddard on the East Coast.
Those people in Baltic, South Dakota, they're sitting there receiving the data.
Yep. Yep, USGS Eros receives all of the data. The earlier satellites, Landsats 1 through 5, I believe, didn't have onboard recording equipment. And so we had a series of ground stations all over the planet that would receive data. And after a period of time, we would get that data. And so without an onboard recording system, we just didn't have any way of downlinking it all at Eros, at USGS Eros. So, but now with Landsat 8 and 9, they have mad onboard recording capabilities, so we can actually downlink the entire planet now to USGS Eros.
Are Landsat images, are they considered like public domain, or do companies and agencies have to purchase?
They are public domain. They are downloadable to anybody with an email address at no cost. And if you download, there's a couple of different ways to download. You can download a whole file, and the TIFF files require a little bit of processing software, which is a little complicated, but there are natural color JPEG files that anybody can use, which is really easy to open with no special software needed. Any other questions? Thank you. And don't forget, pass the stuff back there.
Thank you. Just a reminder that we do this every 3rd Tuesday, so next month, that'll be June 21st, 6 p.m. right here. The speaker for next month is Dr. Frank Benoist. He is our Department of Humanities department head, interim department head. He's going to be talking about Peter Norbeck. Peter Norbeck was the 9th governor of South Dakota. He then went on to become a senator from South Dakota. And during that time, he helped establish Custer State Park, Badlands National Park, Wind Cave National Park. So Dr. Benoist is going to talk about Peter Norbeck's life's work, which is basically conservation and wildlife protection in the Black Hills, and the visitor center at Custer State Park. So, there's also the Norbeck Wildlife Preserve within Custer State Park as well. So that should be interesting. Hope to see you on June 21st. Thank you for coming.
So how are you related to Sam? Right? Yeah.